Hey guys, Larry C here. Do you know the best part about elevator jokes? It's that they work on so many levels. Shout out to you all. Enjoy the video.
Come on now, dog. Come on, man.
Shout out to you all. Hey guys, it's Larry C here, and in this video, we're going to build the next section of notes for the Build the Stats course with me video series. Okay, so let's dive right into it. First and foremost, I have the previous videos guided notes up here, but you'll notice at the top that I changed the name, so I created another file for this. And I usually do that right away because I have the autosave feature on, which I'm kind of a fan of it, kind of not a fan. I find that it's, I'm always too scared that something's gonna, like the power's gonna go out or my laptop's gonna freeze and the data won't be saved. So this is kind of a fail safe for me. But some of the cons of it is that if you don't do a save as right away and you're editing these notes, it's going to basically overwrite the original file via the autosave feature, so you kind of lose it. And that could definitely be like a here's William moment. But okay, so let me just go ahead and change the header here. We're still in chapter 1. This could be section 2. And the name of this section is types of data. So we'll rename this section 1.2, types of data. All right. I'm actually going to start this out with a subsection because I was kind of thinking about this last night and this morning, how I'd like to open this section out. I'm going to just copy this voluntary response sample subsection title, paste it so I can edit it, and I'll take you to the textbook. I have that somewhere. Here we go. Open e-textbook. All right. So go to section 1.2, types of data. And it looks like they have an introductory video. It says here, so the major concept is because a major use of statistics is to collect and use sample data to make conclusions about populations, we should know and understand the meanings of the terms statistic and parameter. I think that's reasonable for sure. In this section, we describe a few different types of data. The type of data is one of the key factors to determine the statistical methods we use in our analysis, and that is absolutely facts right there, big facts. Okay. So their first subsection, I have it load here. Let's see. Here it is. Yes. Parameter versus a statistic. Huge opportunity to do some differentiation here. So that's what I'm going to focus on first. Parameter versus statistic. All right. So the idea that I had regarding this was a little YouTube video while kind of reflecting on how I want to approach this section of guided notes. Thought about an analogy that I heard a long time ago about the blind man and the elephant. So I'm going to go ahead and play that, just a little bit of it for you guys.
There were 6 blind men who grew up in a village in India, and the community kept them safe and shared with them many stories. The men were curious about many of the stories they heard, but they were most curious about elephants. Based on the stories that each of them had heard, they argued about what elephants must be like. The community grew tired of these arguments and arranged for the men to visit the palace, where they were greeted by an old friend from their village who worked as a gardener on the palace grounds. Their friend led them to the courtyard. There stood an elephant. The blind men stepped forward to touch the creature that was the subject of so many arguments. The first blind man reached out and touched the side of the huge animal. An elephant is smooth and solid like a wall, he declared. It must be very powerful. The second blind man put his hand on the elephant's limb or trunk. An elephant is like a giant snake, he announced. The third blind man felt the elephant's pointed tusk. I was right, he decided.
Fair use, by the way. So as you can see, I'm trying to make an analogy here between, well, actually statistics overall. So we have these blind men that are hearing stories about an elephant, and of course it kind of piques their curiosity, so they would really like to meet an elephant in real life, and they have the opportunity to. And of course they're blind, so when they're brought to the elephant, they can't see it whatsoever. So, what's the next best thing that they could do? Well, they could use one of their other senses, which is the sense of touch. And, one of the blind men goes up to it and feels its side. And, based on his prior knowledge of other objects that he's felt, he touches this part of the elephant and concludes that an elephant is like a brick wall. All right. The other blind guy touches the elephant's trunk and concludes that it's a snake, and so on and so forth. And towards the end of it, the video basically encourages everybody's individual perspectives to come together as one whole collective. And I think that it really applies in this particular section, because we can kind of think of the elephant as like the parameter. Okay, so it's the entire object in question. And what these different blind men are doing is they're basically taking samples and making conclusions based on their sample. And when it comes to numbers, which samples are a lot of times numbers, of course, we try to make conclusions about the sample in hopes that our conclusions extend to the population. All right. So it's very, in my opinion, a very good one-to-one connection between, one of the topics of this section. So I am going to steal this YouTube video, and I'm going to create a QR code for it. And I'll go ahead and print screen here. And I'll take this QR code. Oops. Like we did last time, we'll go ahead and open up a copy and paste palette. There's our QR code. And I'm going to say here, to investigate these two definitions and how they relate to each other, let's watch the following YouTube video. Click on the, or actually, scan the QR code to view it on your smart device. Okay, so very bland instructions there. What I'll most likely do in class is I'll say, I'll have the video ready on my projector, and I'll just kind of refer them to this QR code if they want to watch it again at a later day or a later time. So I usually keep some of the stuff from the previous section of notes because I try to stick with consistent notations, like for example the example, or maybe I want to use some more of these call out tables or call out boxes. So if I can preserve any of that, it definitely saves on some time. All right, put this over here and I'll align it to the center. And like last time, I'm just going to check that this link actually, or this QR code actually works. And it certainly does. So we're good to go on that. Now I'm going to take some of this from our previous section and we'll do some definitions. And these definitions I'm going to take from our textbook. Okay, a parameter, you know what, I'll leave that blank just to get a little interactive, little bit of engagement on the student side. Okay, is a numerical measurement describing some characteristic of a population. All right, that's our first definition. Oh, we want that singular. I lost my bullet point. Let me put it back in there. It'll be a sizing thing. Lord have mercy. There we go. A little bit of spacing between the two definitions. Put A, Canadian's favorite letter. Okay, A. Try to line that up. Is a numerical measurement describing, thanks autofill, some characteristic of a, not population this time, but a sample. Where's my mouse go? All right. So the first bullet point definition is for parameter. Second is for a statistic. Something that the author offers is just not necessarily a mnemonic, but just some phraseology that can help people memorize which corresponds to what. So I'm going to take this call out box and I'm going to actually put a title in this. Call this a tip. To help remember which definition applies to the population or statistic, think ... Okay, I'm going to put this in quotes, population, do a little arrow. So what I did for that arrow was just a couple of consecutive hyphens with the greater than symbol. All right, formats it that way. Population parameter. Okay, both start with P. And then for this next one, it'll be statistic implies sample. All right, and I'm just gonna decrease the spacing between the two. Maybe might do my size 2 font trick just to give a little bit of gap there. All right, and this box doesn't need to be that obnoxiously wide. Do it as that. And I'll hit save, even though it auto saves. Can never be too sure. All right, so I'd also like to give a little visual of this just to really drive the point home. So I'm going to go to Claude, and I did this right before I hit the record button. And this is just a graphic describing the differences between a parameter versus a statistic. So in these blue boxes, we have stuff related to the population, whereas in the green box here, we have stuff related to the sample. So it's color-coded. You can see that it defines population as everyone or everything of interest, and they have a few of the blue dots circled with green. And this is the nice thing about Claude, is it kind of understands what route you're trying to take after you use it for a while. But I'm not sponsored by Claude, by the way. It is super helpful though. Okay, so the idea here is that, all right, here's everything of interest, but if I am not able to examine every item in this population, then the next best thing to do is just to select some objects from this population, ideally simply randomly, which we are going to get into in a different video. And we'll kind of draw some conclusions based on that. So you can kind of think of, you know, this as the elephant, the collection of dots as the elephant, and then the blind men's sampling of the different parts of the elephant. All right. And then it says a parameter, a number that describes the population, uses Greek letters mu, that is sigma, and I believe that's rho. Whereas a sample is a subset drawn from the population, and that would be a statistic, a number that describes the sample. All right, uses these letters x hat, lowercase s, and p hat. So those notations aren't absolutely critical to have in this part of the notes at this stage, but I'll leave them in there since I think it's going to be a little too difficult for me to remove those. So I'll go ahead and print screen here. Take that, copy and paste palette. And I'm going to crop the parameter versus statistic out. We already have that kind of interwoven into our notes. Picture format, going to go to correction. I'm going to sharpen this. Maybe go down a level. Actually, I'm going to go back. Yeah, so this will be better for printing purposes. And yeah, so we'll just, well, actually, let's see what this looks like in a grayscale. All right. I'll leave it in the original. So copy and pasting it into the section of notes, and we'll bring it down here, we'll shrink it down a little bit. And I'll leave some, space for margins on the side for us to annotate. Maybe write down that, the whole collection of dots right here is kind of similar to the elephant, whereas this right here are the, blind men's observations. So that's the first part of this section of notes, and we're going to do an official example. I'm going to copy and paste this, and I'm going to change this from note to example. I'm going to take an example from our textbook. Textbook. Apologies if you hear the lawnmower back there or in the background. Okay, 15. Let's see if it's 1-to-1. Yep, here it is. Alright, so we kind of saw this in the previous video that you actually get the HTML code for the numbers that are part of the problem, but those are pretty quick and easy to fix. In a Citrix security survey of 1,001 adults in the United States, it was found that 69% of those surveyed believe that having their personal information stolen is inevitable. Ooh, it's kind of doom and gloomy. Okay, so we'll change that coding to 69%. Identify the population and the sample. Is the value of 69% a statistic or a parameter? All right. Sometimes it fixes the typesetting. Okay, so if you're wondering about, the answer to this, the population is, as it says here, everyone or everything of interest. And so it says in a Citrix security survey of 1,001 adults in the United States. So in this case, right, so that's actually going to be the population. So I think of it as like, all right, what in this survey, assuming that we're just confining things to the United States, what could possibly, be of interest to us? And there's a little bit of context here that helps us with that. What's of interest to us are adults in the United States. All right. Obviously, it's going to be damn near impossible to survey every single adult in the United States. And this is kind of the point of statistics is, okay, well, what's the next best thing that we can do? Well, depending on your sampling method and how well the survey is crafted and so on and so forth, you take a certain subset of the adults in the United States and you run some statistics on those. And there are metrics that we're going to go over later on in the course that would give us some confidence as to the statistic, being a good indicator of the parameter. All right, so the population would be the adults in the United States, and we're sampling 1,001 of them. All right, now anytime we get information about the sample itself, that is a statistic. Okay, so it says here it was found that 69% of those surveyed believe that having their personal information stolen is inevitable. All right, so we identified the population and the sample, and 69% would be a statistic. All right. Now, the reason why it's a statistic versus a parameter is because the 69% corresponds to the 1,001 adults. All right. This might not actually be true about, the entire adult population in the United States. All right. This is some evidence, but not necessarily proof of that. If we were to sample all of the adults in the United States and come up with the percentage from that, then it would be a parameter. Okay. So the idea of stats is to, ask ourselves, all right, well, is the 69% of the 1001 a pretty fair approximation of the percent of the entire adult population in the United States? All right, so I'm going to leave some room for that for my students. All right. Okay, so I'm going to segue us into the next subsection of 1.2 with a question. All right. So I'll phrase it this way, and I'll do it italicized in the middle. Okay. Actually, not a question. Because I wrote it down as a note, not a question. So I'll do a note here. Okay, so how we study and learn more from the statistics is based on the types of data we have. All right. So what I'm trying to emphasize here is that, I'm going to start to emphasize that the type of data that we are examining kind of, indicates what sort of statistical procedures are valid and reliable for that particular data. So there are different ways that data can be presented, and we're going to go ahead and go through those different ways right now. All right. So I'll make another subsection title. Do my size 2 trick. And I'll say quantitative and categorical. I'm going to lead off with a couple of definitions here as well. Okay, so this is for the type of data. And I'm going to put parentheses or, not or, numerical data. This is coming from the textbook as well. Consists of numbers, italicized, for emphasis, of course, representing counts or measurements. So this type of data we can do math with. Lots of good math. And what's better than math? More math. Okay. The other type parentheses or quality. Okay, so there's a few different words used for this. Qualitative or attribute. I like that word. All right, so the first one is going to be the definition for quantitative data, and then the next one is going to be for categorical data. And this is defined according to our author as data that consists of names or labels not numbers that represent counts or measurements. Okay, but I'm gonna make a note for this. This is something that could be confusing for students, so I want to make sure that I help guide them through that. Categorical data are sometimes coded with numbers where the numbers are meant to replace names. Okay, so be careful when assessing whether it's appropriate to apply mathematical analysis to these data. I'll say that. All right, so for example, if you look at the Detroit Tigers, you know, they have jerseys and numbers on their jerseys, and those numbers really don't have any mathematical meaning to them. They're basically just labels for the people. All right, so that's kind of what this is getting at, hinting at here. So let's see. Give some examples of this. So I made a note to reference a table in the textbook. Let's see if I can get the page number for that. So this textbook, the back of the textbook has answers to odd problems, but it also has data tables such as for the normal distribution, the chi-square distribution, and so on and so forth. But there's also an appendix for data sets. And the data set that I wanted to use for this was cars. That would be data set 35 if you're using the same textbook. It's page 761. Go ahead and time warp there. This one's not too bad either. Ooh, I have to zoom in on that. Okay, I'm going to screenshot just a portion of this. I think that gives enough variety. Alright, so I'm going to try to come up with some instructions for this. Okay. Identify each column as quantitative, spelling with Mr. C, data or categorical data, colon. Shut this down. So what I'll probably do with my students is just either put Q or C above each column heading. So model car, that would be categorical data because it's basically just names of cars. And then size would also be categorical data because that is a certain type of category. So maybe that's small, medium, and large. But the remaining columns, these would be quantitative data because these are things that are basically measured and that the numbers have meaning for. All right, so 2,844. That's not a number that replaces a name. This is actually how heavy the car is, and with all these other different weights of the cars, we could actually do some meaningful math or stats with this. We could look at the average weight or the median weight, so on and so forth. Same thing with the length of the car, the braking. Maybe this is, maybe the units for this are seconds or milliseconds. So that might be clarified in the back of the textbook. Okay, so that's actually braking distance. All right, so braking is braking distance from 60 miles per hour. Okay, and yeah, okay, and so maybe this might be something that is worth mentioning when going through this example. All right, there are 12 cars in each category: small, mid-size, large, and SUV. All right, so this is categorical data. Whereas everything else, you can see it has units of measurements to it. So pounds, inches, feet, so on and so forth. City stands for the fuel consumption, miles per gallon. Highway, same thing, except for freeway driving, and so on and so forth. All right. And let's see, cylinders is the number, so that's pretty obvious there. So I think that would really help them to separate out the difference between categorical and quantitative data. And in my opinion, this is kind of like the warm up for the main bulk of this section. So for the rest of this section, at least for the notes that I'm making here, we're going to do some things to help students, just kind of further break down quantitative data and also the different levels of measurement. So with that, let me create another subsection. Maybe I'll leave some space for annotations and make this a little bigger. All right. Discrete. Actually, okay, discrete and continuous data. So I'm going to lead off with the statement that is from the textbook. Quantitative data can be further described, spelling with Mr. C, by distinguishing between discrete and continuous types. I'm going to bold this, discrete and continuous types. So a lot of definitions in this section, so that's going to kind of, be the reason why towards the end of this video I'm going to show you how to not make this like a death by definition section. I know for me personally, if I just have a section full of definitions and no learning aids with it, I'm probably not going to remember any of that. So, and I figure if I'm not going to remember any of that, how are my students going to? So anyway, maybe just to save on some time, I'll just screenshot the definition from our textbook. This is on page 16, because these definitions are quite lengthy. Here we go. Well, I'll copy it. Yeah, let's just do this. Wait a minute. What just happened? Can do a new flashcard? Huh. Well, that's pretty neat. Front. Discrete data. Let's see what this does. Go flashcards. Ooh, that's cool. I'll have to show them that. Apparently you can make your own flashcards directly from the textbook. I like it. Okay. Definitions. PowerPoint. Discrete data. What I did to do that with keystrokes is that I just held Control and pressed B down. Control bold, I think of it as. And then oops. Continuous data. Continuous data. Result from infinitely many possible quantitative values where the collection of values is not countable. That is impossible to count the individual items because there are at least some of them that are on a continuous scale, such as lengths and distances. And yeah, so I think of the real number line when it comes to this. The set of real numbers is uncountable. And that's because it's a continuous spectrum of numbers. So, between any two real numbers is also a real number. Between those two is another real number. And so it'd be impossible to count all of those real numbers. Okay, so it says it's impossible to count the individual items because at least some of them are on a continuous scale. I think I just read that. Such as lengths of distances from 0 centimeters to 12 centimeters. Okay. Put that in there. And the book has a really good graphic for this. I love this. That's gold right there. But I have another one that I'm going to show you guys that I thought about. I'm actually going to paste this twice. I don't know if it's just me, but if discrete data is being featured first, I'd like the discrete data image to go first. So what I do for that is I basically to separate these out. Well, I guess what you could do that might be a little easier is just, screenshot this individually and then screenshot that individually. Or something else that you can do is create 2 copies of this and then crop one of them out. Alright, so what I do for that is I go to picture format. After I highlight the picture, I hit crop, and then I'm just going to drag, and you can create 2 separate individual images. Alright, so discrete data. Zoom in on that. Increase the contrast on this. Now it's looking a little grainy. Let's see what that looks like in grayscale for when we print it. Alright, that's not too bad. I'll leave it in grayscale. Okay, and I'll go ahead and copy and paste this. Text. Okay. Alright, so let's make sure that these make sense. Okay, discrete data result when the data values are quantitative and the number of values is finite. Alright, so what makes the digital thermometer finite is that, well, the highest level of accuracy is 1/10 of, 1/10 of a degree. So, there's nothing in between 36, is that's Celsius. Okay, so there's nothing between 36.6 and 36.7 according to how accurate that reading is. All right. Whereas, if you have this type of thermometer, it's a little hard to tell, but you can be a lot more accurate with this sort of scaling. And I like to think of it that way is, when the spectrum becomes nearly complete, that's continuous. Whereas if there's some gaps between values, then that's discrete. You can kind of think of discrete data as kind of like having their own personal bubble. All right, so that might be a good thing to convey to students. I gotta wrap that behind text. Oh, it is. Okay, let's see if I can move it. That's a little too big still. Alright, so I know that in the last video I mentioned I try to keep my notes, no more than 4 pages, but as you're seeing, there's lots of graphics that I'm including in this one, so it's okay that you go a little bit past that. I'm thinking that at this point maybe the students are almost fully saturated with information. So I'm going to start to get a little bit on the creative side here, because, and this is kind of like a main event, Well, actually, let's do an example. I don't have like an official example for that. Okay, here we go. Alright, this is a rather quick example anyway. Which of the following describe discrete data? And their formatting for their answer choices, multiple choice using lowercase letters. Okay, the first is the exact heights of all NBA basketball players. Option B, the number of people surveyed in each of the Gallup polls preceding the next presidential election. Very patriotic option. And then the last option is the exact times that randomly selected students spend on smartphones during the preceding week. Oof, man, that's always a tough one to look at. I don't know if you guys get like weekly, what is it, phone health notifications where your phone tells you, you know, how much you used your phone the previous week. Ooh, man, sometimes that makes me feel awful. But in case you're wondering, the correct option here is option B. And the reason for that is because we can get really granular with how we measure the exact heights of NBA basketball players. Like you can get down to the very nitty gritty when you're measuring that. So maybe your scale goes down to millimeters. And it can go down even further than that. And same thing with time. Time is continuous, so generally speaking, when we're talking about different time values, as long as they're not categorical data time values like 1776 or 2026, if we're talking about time, it's usually on a continuous scale. So we could get really granular with how we measure the exact times that students are spending on smartphones during the preceding week. All right. So next is levels of measurement. All right. So I think I'll do death by definition one more time. Let's see what format I want to use though. I'll use this format, so I'll have us fill in the words for each of these, but I'm going to quickly follow it up with kind of like a more condensed version of the definitions. This is page. Yeah, you know what? I'll insert a statement here to kind of motivate this last thing. Another way of classifying data is to use 4 levels of measurement. as defined below. Shout out to Five Below. Okay, maybe I'll tweak that a little bit because there's more info I want to give. It is important to distinguish between these levels so that you can decide the best type of statistical procedure to use when analyzing data. Yeah, I think that's fine. Alright, so hopefully I can fit these definitions on this page. I'm not feeling very hopeful about it though. Alright, we'll just kind of see where it takes us. Oh my gosh, this right here, measuring disobedience. Let me read this to you guys. How are data collected about something that doesn't seem to be measurable? That's kind of a very tricky thing to encounter when trying to convert qualitative data to quantitative. But you might be familiar with this study if you've done any work in the field of psychology. It says psychologist Stanley Milgram devised the following experiment. The researcher instructed the volunteer subject to operate a control board that gave increasingly painful electrical shocks to a third person. Actually, no real shocks were given, and the third person was an actor. The volunteer began with 15 volts and was instructed to increase the shocks by increments of 15 volts. The disobedience level was the point at which the subject refused to increase the voltage. Surprisingly, 2/3 obeyed orders even when the actor screamed and faked a heart attack. So let me put you up on some game here. I've heard that if you're ever asked to do some sort of study like this, the scientists are not actually studying the experiment itself. Okay, they're actually studying you. So, for something like this, you're being asked to show how, I don't know. Well, I don't think that they'd frame it this way, but what they're not studying the actual different increments of voltage that you're increasing by. They're studying to see when you'd stop. So yeah, that's something to be aware of. All right, so where are we at here? Go back. It's nominal. This is actually, oh, there it is. There it is. This is out of order in the physical copy of the textbook. I'll have to make a note of that. Okay, so this is a definition for nominal. Make a blank space for that. The nominal level of measurement is characterized by data that consists of names, labels, or categories only. Well, this is kind of like categorical data. The data cannot be arranged in some order, such as low to high. So if you surveyed everybody's favorite color, you can't really, there would be no meaning in which you list out, the favorite colors. It doesn't really make a difference if you write out the word blue first or the red first, or the color red first. All right, the next is ordinal. Editing with Mr. C. I keep on forgetting to click that copy button. Lord have mercy. Okay, data are at the ordinal level of measurement if they can be arranged in some order. So if you are, if you practice religion, let's say the Catholic faith, then you're probably aware of something known as ordinal time. And order is kind of, the root of that word ordinal. And so, there's a particular sequence of events that go in a particular order. All right. So, maybe it's like the fifth Sunday of ordinary time. Then, a week after that would be the sixth Sunday of ordinary time. And these are all, different time periods that occur in a particular order for a particular reason. Okay, so it says here, data are at the ordinal level of measurement if they can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. So, I mean, if we took the difference between the sixth Sunday of ordinary time and the fifth Sunday of ordinary time, I mean, there's not really much context to it, all right? And that's okay. We're actually most concerned about the order of the events, the how they flow, as time goes by. Interval is next. I did it again. Forgot to hit that copy button. Ditch this. So this is kind of, all right, this one and the next one are a little bit difficult to differentiate. So this is definitely where you as an instructor have got to devise a plan to make sure that these really stick to them. So I have an idea for that. I'm sorry, it's taking me a little longer to get to that though. All right, so data are at the interval level of measurement if they can be arranged in order and differences between data values can be found and are meaningful. Data at an interval level do not have a natural zero starting point, which none of the quantity is present. Okay. So, for example, like temperature readings, it would make sense if, somebody had a temperature of 98.7 and you compared that to somebody with a temperature of 96.8. All right. So there'd be some context concerning the difference between those two measurements. But temperature doesn't necessarily have like a natural zero with it. All right. Obviously, there's 0 degrees Fahrenheit, 0 degrees Celsius, and 0 degrees Kelvin. But those were all just sort of decided on, by convention, all right? I know there's such thing as an absolute zero, but is it, I guess, hypothetically possible to maybe redefine that as like at like an even lower kinetic energy level, not to get all sciencey or, physics teacher here, which I'm not. Okay, but you know, if there's no naturally occurring zero, that actually makes sense to the problem at hand. But differences between the values do give you some context, then that is definitely interval level of measurement. Let's do the last one, ratio level of measurement. I'm going to remember to hit the copy button. We'll unbold this. Okay, data are at the ratio level of measurement if they can be arranged in order. Differences can be found and are meaningful. So this kind of has some characteristics of the interval level of measurement. But the major difference is that there is a natural zero starting point. Zero indicates that none of the quantity is present. For data at this level, differences and ratios are both meaningful. So let's say that you're completing a test for a stats class, then it's likely that somebody could finish after you or before you. Not everybody finishes a test at the exact same time. And of course, you could find the difference between your time and one of your fellow peers' times, and it would have some context to it. But also, too, there's a natural zero for this. Not that I've ever seen anybody do it, but you know, it could take somebody no time to complete the test. Maybe they actually didn't show up for the test that day, which I'm not even sure if you would count that as complete. Probably not. But but zero would make sense in that context because you know zero time is something that is tangible. Okay. All right, so obviously not all the definitions fit on that little section of that page there, which is fine. I'm going to take something from the textbook that I found to be really helpful, and it's this table right here. Levels of measurement. So this is kind of a summary. Let's just contrast here. Maybe I'll segue this. Say below is a brief summary of each level of measurement. Okay. All right, so let's go over this. We got ratio, there's an actual zero starting point, and ratios make sense. So such as heights, lengths, distances, volumes. I'm not really liking the contrast here. Maybe that's better. Okay, interval differences are meaningful, but there's no natural zero. So body temperatures in degrees Fahrenheit or Celsius. Ordinal data can be arranged in order, but differences either can't be found or are meaningless. So ranks of colleges in U.S. News and World Report. Okay. Nominal categories only, data cannot be arranged in order, so eye colors. That's kind of a good example there. They do offer a tip. So I'll make another call out box for this tip, just for emphasis. Ooh, went too far. Say to distinguish between ratio and interval, you can apply the following. I will left justify this as well as this. Number one, they have something known as the ratio test, not to be confused with the Calc 2 ratio test. And they actually have a long, it says focus on the term ratio and know that the term twice describes the ratio of one value to the other. So to distinguish between the interval and ratio levels, ask yourself the question, does use of the term twice make sense? Okay. Let me put it this way. Would doubling make sense? All right, and so what I mean by that is if you were to take a data value and double it, would it be feasible? Like, would it actually have some meaning in the problem at hand, the context of it? And the next one is true 0. Okay, so it says for ratios to make sense, there must be a value true 0. Okay, so I'm going to phrase it this way. Would is 0 an arbitrary value? All right, so going back to the time it takes to complete a test, 0 is not arbitrary because 0 actually has some context to it. 0 makes sense. It would mean that, you know, takes 0 time to complete a test. Okay, or if you are measuring lengths of things, something could potentially have no length whatsoever. All right, in which case that's definitely plausible and it has some meaning in the context. So I think these are kind of a couple of good tips. And I'll just kind of center this here. You know what? I'm going to crop this just to make this table a little easier to format. Oops. Okay, where are we at here? This has got to be this is page 4. Okay. That's good, because I thought we were already on page 5. We're about to be, though. Perfect. All right, we'll do some examples. All right, determine which of the 4 levels of measurement best describes the given data. Apologies about that. We'll go to the textbook. This is page 25 that this is on. I'm just going to copy and paste some examples from the textbook. Let's see. Okay. Ooh, this one's cool. Movie rankings. Maybe I will keep the subject in there. Alright, so I'm using numbers for this one. Oh, crap, I forgot to click the copy button. I'm using numbers for these scenarios because I don't want students to confuse that with, you know, like answer choices like the letters were for this one. So, copy, scale of 0 to 5. I'll leave a blank space so we can write the answer down. Okay, so the answer to this one would be ordinal. And how we know that is because we look at the brief description of ordinals. The data can be arranged in order, but differences either can't be found or are meaningless. And if you look at the example, this is kind of similar to a ranking. Okay, so students rate 10 documentaries using a scale of 0 to 5. So, you know, we could assign the ratings to each one of the 10 documentaries, and then we could just order it. You know, we'll group the documentaries with a score of 0, if any, then documentaries with a score of 1, and so on and so forth. But you know, the difference between the rating values themselves is, you know, doesn't necessarily have like a good amount of or an obvious meaning to it. You know, like what's the difference between a 4 and a 5, or what's the difference between a 2 and a 4? Okay, there's a little bit of subjectivity to it. All right. This is a good one. Art history. Okay. Do a little spacing here. 5. All right, in the art history course, students are asked to identify the painting styles, abstract, classical, expressionism, etc. So those are basically names or categories. So that would be nominal, a nominal level of measurement. criminology. I forgot to hit that copy thing. Dang it. Okay, in the criminology study, the lengths of prison sentences are obtained from randomly selected subjects convicted of auto theft. So I would consider this to be ratio because there is a natural zero. Somebody could get zero sentencing. And would doubling make sense? Well, yeah, I mean, you could easily have two people doing auto theft where one of them has twice as long of a sentencing than the other. Or, you could do ratios like if one person has 1 year of sentencing and the other person has 10 years of sentencing, then the ratio of the first person to the next person is 1/10. All right. So ratios would make sense in this case. So far we have ordinal, nominal, and ratio. We need one for interval. Okay, so let's look at these examples. $25. Oh, I remembered. Okay, baseball statistician Bill James records the years in which Baseball World Series is won by a team in the National League. All right, let me just do a little bit of formatting here. No, that's good. This is good as well. Okay, that would definitely be interval because differences in years would make sense. So you could say that it's been, I don't know, 50 years since the Lions have won a Super Bowl. But there's no like natural zero for it. That would actually like make sense in the context. So like year zero, that doesn't really make a whole lot of sense there. So you have intervals that can be measured, but there's no like zero, natural zero, and also like doubling wouldn't make sense either. So like doubling the year 2026, that doesn't really do anything for us mathematically. Doesn't really give us good math to do. So this would be considered interval. Hopefully that makes sense. Okay, so for this very last thing, which I'm going to consider like a main event here, I'm going to show you guys something that I was thinking about last night. And this is inspired by my youngest son, who does a lot of, gaming, and in between gaming, he'll watch YouTubers, and sometimes these YouTubers are gamers themselves, and sometimes what they'll do is they'll have a video where they're like ranking different things into like different tiers, and what I think I'll do is do like some sort of sorting activity. So let me call this levels of measurement sorting activity. Very creative. Maybe to spice it up, I'll change the font style to something a little more fun, like that. Okay, dreaming out loud. I'll increase the size, and I will center this. And let's think about some instructions. Okay, I was originally going to make this a think, pair, share, but I think I'm going to do it a little differently. Kind of like a 4-quadrant approach. So what I mean by that is I'll basically just make like 4 teams with my group of students, but here are the instructions. With your teammates, determine the level of measurement for each of the items designated for your group. Okay. So there's going to be a group 1. And you know what, I'll say write the how should I qualify this? Okay, write the data. Yeah, write the data in its corresponding tier. Alright, group 1. Okay, so what I did is last night I compiled a list of the different majors from my most recent sections of elementary statistics online, and I'll show you what that looks like. Okay, here we go. We're in business. So these are the different majors that my students indicated in a personal introduction discussion post, spanning the past 3 semesters. Well, actually, this current semester and the 2 prior to. And you can see there's a large variety. And these are quite common. I've been teaching online stats for a number of years now, so I would say it's maybe a decent representation of what I could potentially be seeing in my upcoming fall semester stats class. So the going back to the YouTube conversation about my youngest son, so sometimes the ranking system that they'll use is like a tier system, and I'll show you an example of what I mean by that. So you know, a tier like this where they'll have like S rank, then A rank, then B rank, C rank, and so on and so forth. And if you're a gamer watching this, you probably know what I mean. So I'm just going to kind of spoof off that, and this is something that I'll most likely print off separately or try to at least include in the note packet itself. Let's actually see if I can do that. Copy and paste. Oops. Actually, you know what? It might make sense to make this a separate file, because layout, the most natural layout would be landscape. And I'll make the margins narrow, and now I'll paste this. I'll just try to make this as full of a sheet as possible. All right, and obviously it's going to be difficult for them to write on top of the coloring here, so I'm going to see if I can change the color. Yeah, I think that's probably good. Or, here's an even better idea. I think I can insert a text box. If we want to keep the colors, give them a color copy of each of these. Just copy and pasting them. Alright, so it's not perfect, but I think it should do the trick. And if you want everything to just kind of be attached amongst themselves, you can highlight each one of these by holding the control and left clicking them, and you go to shape format, you click on this icon and you tell it to group, and then I'm going to select that grouping with the actual picture itself, and I'll group those two, and everything should move together. And maybe underneath this I'll put, oh, not that. Notes. So if they want to write down any sort of commentary that they're hearing from their teammates, they can do so here. I'm going to save this as the section 1.2 activity. Section 1.2 sorting tier activity. Math 122 fall 26. Okay, so going back to these majors, what I did is I saved this file and I fed it into Claude. And I prompted Claude to say, can you come up with examples of nominal, ordinal, interval, and ratio data for the bullet pointed items in the attached document? And so it attempted to do that, but not the way I wanted it to. So it gave me the 4 categories and just kind of sorted the majors into each one of them, but I actually wanted it this way. So I reprompted it. I said I mean cases in which they'd see the 4 levels of measurement in each of their fields. So what I'm going to do is go back to this right here. And essentially just going to copy and paste some of these examples. So, maybe I'll take, copy that, paste it for this. Then I'll go to ordinal for the next one. Then I'll go to interval for the next one. And I'll go to ratio for the next one. And then I'll kind of go in reverse order. So from kinesiology, I'll select the ratio. And then interval. And ordinal. Then nominal. And we can continue on going in this way. Maybe I'll take nominal again. And then interval. Then maybe another ordinal. And that can be our first group's list of examples. And so they would just, probably abbreviate some of this and just categorize these into the different tiers. Okay, so, for nominal, they would write down type of business entity, okay, in that tier. IQ or standardized test score, no crew 0, so they would write that in interval, and so on and so forth. Then create a list for group 2. Then group 3. And then group 4. Of course, you do want to maybe ask somebody from their team to maybe share with you their like a master copy of this tier list. Or what you could do instead is, and this is something I had Claude help me build as well, I have like these little cards here that I had it made where they can see, exactly where their data would fit. So, group 1 would see that the type of business entity is a nominal example, and this would fall into the area of business and finance. All right, or maybe a different group has vulnerability severity, low, medium, high, critical, and that would be ordinal, which they could see that in something like cybersecurity and technology. So what I think I'll do is I'll print this off for each one of the students, and it'd be a way of them checking their work, and that would be the end of the section. So yeah, it looks like it needs to be a little bit better formatted, but this video is already quite long enough, so I think that's where I'll leave it. If you watched all the way through, thank you so much. If you have any questions, let me know. Otherwise, it's been another fun day creating some notes with you all. And let's boss up, and I'll see you in the next one. Shout out to you all.